Hello, this is Maths with Lemon, and in this topic we will see how to solve a system of differential equations. Let's see the problem. Find the general solution of the following system of differential equations. Now, my first move is to write my system using matrices. So basically, I will have derivative of x, derivative of y equals, this one can be written as a matrix of these two elements, 2, 3, 1, 4, times my variables x, y. Now, the first thing that I have to do when I'm trying to solve a system of differential equations is find the most important thing, the eigenvalues and eigenvectors. How I do that? First, I take my matrix 2, 3, 1, 4. Then, to get my eigenvalues, I will subtract from my matrix, I will subtract lambda times my identity matrix. So it's going to be minus lambda, 3, 1, 4 minus lambda. And then this one should be this is my matrix, and now I must find the, let's say that this matrix is called A. Now I have to find my determinant of the matrix A, which is going to be equal with 0. So I'm going to have 2 minus L times 4 minus L minus 3 times 1. It should be 0. I'll make the multiplications. 8 minus 2 lambda minus 4 lambda plus lambda squared minus 3 is 0. Now lambda squared minus 6 lambda plus 5 is equal with 0. Now the only thing I need to do is find the eigenvalues, where the eigenvalues will be after solving the quadratic. Lambda 1 will be 1 and lambda 2 will be 5. Now I found my eigenvalues. These are my eigenvalues. Now the only thing I need to do is to find my eigenvectors. So to find my eigenvectors now, my eigenvectors will be for lambda equals 1 for the first one, I will have 2 minus 1, 3, 1, 4 minus 1 times x, y, so as to find the values, which is going to be 1, 3, 1, 3, x, y, which is going to be x plus 3y, x plus 3y. Now these eigenvectors I have to find the my eigenvector, you see that both of these two equations, they have the same solution. So basically x plus 3y should be equal 0. X plus 3y should be 0. So from here x equals 3y minus 3y. So basically now if I have here my vectors that they produce the whole solutions, I'll substitute minus 3y, y, and if I'll pull out the y from here as a scalar, I will have minus 3, 1. So an eigenvector of that one is minus 3, 1. Here this one should be 0. So for lambda equals 1, my eigenvector is minus 3, 1. I continue. For my other lambda value, which is 5, I will substitute my lambda value on the matrix, minus 5, 3, 1, 4 minus 5 times xy. So it's going to be minus 3, 3, 1 minus 1 times xy. So basically this is going to be 0, and if I'll make the multiplications, you see again I have the same equations. 3x plus 3y is 0, x minus y is 0, and from here I will get, therefore x is y. So if I'll have my vector xy, I'll substitute instead of xy, so it's yy. I'll put that outside my vector y, and I will have 1, 1. Y times 1, y times 1, y. So the eigenvector for the eigenvalue 5, I get an eigenvector of 1, 1. Now, since you found the eigenvalues and eigenvectors, here are my eigenvalues and eigenvectors. Now, the only thing is to do is to write the solution. Now, the solution is always will be in this form. X, y should be equal a variable times e to the first eigenvalue times the corresponding eigenvector plus b, another constant. These are based on the initial conditions. We will see another example. Times e to the second eigenvalue times my second eigenvector. That's the general solution. So now if I'll substitute my eigenvectors and the eigenvalues, I will have xy should be a times e2, the first eigenvalue, times t, because the variable is t, times 1 times t times the first eigenvalue is eigenvector minus 3, 1, plus b, e, how much is the second? 5, so 5t times my second eigenvector. And that's the general solution of this system of differential equations.